Good evening, folks, and welcome to the talk on Azure Site Recovery. I'm Manoj Jain, a Principal Program Manager with Microsoft. Been with Microsoft for about 16 years and the last 5 years in disaster recovery. I have with me Christian Nies from LumaGate. He's going to co-present with me. So what will you learn today? Learn about how long Fira Barcelona is. It's really long. Yeah, no, just kidding. So today we'll learn about the breadth of Microsoft's BCDR solution. We'll go deep into how you could use Azure as your site recovery, where you could replicate into Azure and recover. And finally, Christian will talk about his experiences working with one of his key clients and the learnings from there. So, as such, though business continuity, there have been products for a long time now. It's fairly an underserved market. Some of the reasons are listed here. I'll not go deep into it. I'd like to go deeper into the Azure part of it, so therefore I'll keep the overview short. A couple of things to note here is the untested DR. The fact that testing of DR is fairly complex, non-repeatable, leads to a reduced confidence about disaster recovery. And this also, of course, leads to increasing costs. And Microsoft took a holistic view at this and decided to attack it in a breadth view, where some of the things we invested in are listed here. A couple of things which I would like to talk about is implement testable solutions for data recovery, and that will directly lead to cost reduction, simplification, and therefore operational stability. How did we achieve that? By investing in multiple products with breadth. For example, failover clustering for the virtual machines, guest clusters for the applications, Windows Server backup for your operational needs, DPM to meet enterprise or large-scale backup, and then we integrated Windows Server backup and DPM with Azure to help you increase further scale and reduce costs. And then finally, but not the least, is Azure Site Recovery to meet your disaster recovery needs for virtual machines, for physical, including VMware virtual machines. Let's go deep into Azure Site Recovery. So the DR solution. To talk about it, I'll first introduce you to the Microsoft's DR stack, which starts with the compute, storage, and network, the fabric, the traditional fabric at the bottom, which is primarily Hyper-V driven. And then on top of it, you run the virtual machines, within which you run the applications like IIS, SQL, and so on. Traditionally, people use storage replication for protecting the storage. You use Hyper-V Replica, released in Server 2012, for protecting your virtual machines. And for your applications, you might be using application-specific technologies. In the past, to get a single view or an integrated solution was very complicated, or if not impossible. That's because you had to take multiple vendors which would work with all these technologies to put together an end-to-end DR solution. So to solve that problem, we introduced Microsoft Azure Site Recovery. This can actually orchestrate all these technologies and more. So for example, we started with SQL Always On and VM replication with Hyper-V Replica. That was back in January 2014 when it went generally available for Azure Site Recovery. Then we recently acquired a company called InMarge to help protect VMware and physical. Now it's common for people to have physical Hyper-V and VMware, at least 2, if not 3 of these large enterprises, hosting service providers. Having a single vendor cater to all of this will definitely help reduce cost and simplify operations. That left the storage replication piece, but just recently, 2 days back, we announced that we will also orchestrate SAN replication. So with this, with one single solution, you're able to actually protect your applications, orchestrate the replication and recovery of your virtual machines, as well as storage, and not just limited to Hyper-V, but VMware and physical. So introducing the Azure Site Recovery orchestrated DR through the same. And here you'll notice a lot of scenarios being shown in the single slide. On the left, we have on-premise to on-premise, which could be enterprise to enterprise. It could be hoster to hoster. It could be enterprise to hoster. And all of them could be using either Hyper-V replica or SQL Always On or SAN, like I talked about. The next, on the other side, the second one is where we are using VMware to VMware using in-merge. You could protect, using in-merge from VMware to VMware or physical to VMware. The third one, which will be the focus of my talk, is primarily protecting your on-premise into Azure. Okay? Not me. On-premise to Azure, primarily for your Hyper-V host. And then the last one is, yes, we are announcing that we'll soon come out with a way for you to protect your, the slide, someone doesn't like that slide. VMware to Azure or physical to Azure, that's coming soon. And the key features listed below, for example, you get near zero RPO, you get minimal RTO, recovery time. RPO is recovery point objective, RTO is recovery time objective. So you're able to get consistent, repeatable RTO, and you're also able to actually get testing without impacting your production or without impacting your replication. So we are able to cover the entire gamut of environments that you might have through Azure Site Recovery. So with that, that was the overview of the DR solution that Microsoft has. And let's go deep into how you could use Azure as your DR site. So this is a diagram showing multiple customers protecting into Azure. You have customer one, who has SCVMM. You notice a DRP, that's the disaster recovery provider. It's a small agent that you need to, or a provider that you need to install on your VMM. Same thing customer two has, and then you could protect into Azure. What are the use cases for which you would use a disaster recovery to Azure? Clearly, one, there's been a proverbial single click or a red button to get disaster recovery. I'll show you how we've achieved that using our recovery plan. So you're able to actually get a single click application recovery. Compliance, a key thing on top of IT Pro and CTO's mind, but the reason people do not go for compliance is when you do testing, it starts impacting your production. You either have to shut down your production or it might impact your replication. We have zero intervention testing, so therefore you can get your compliance. In case you hear of a disaster like a hurricane or a typhoon coming up, you can do planned failover to avoid the disaster. And then, of course, you can do unplanned failover. Unlike some of the other compete in the market, once you are in Azure, even though you might allow Azure one to stay there, we allow you a fail back. We give you an option where you can actually fail back as a first-class button, a first-class gesture, where you can actually fail back. A lot of dev test is impacted because there is no way to do a staging environment. You have a lot of production data. People would like to test it in a staging environment with production data and then deploy. You could easily use Azure using its test failover mechanism, where you actually do a test failover. It'll bring up the same production VM in an isolated network. You could run your test against the same, and then once you are satisfied, deploy it. Of course, last but not the least, you could actually do planned migration to Azure. Like once you love Azure, you want to stay there, you could just use ASR, the short form for Azure Site Recovery. You could use ASR to move into Azure. How does it work? I'll give a quick overview of it before getting down to the demos. So there's an initial configuration step where you do a sign up, you create a subscription, and then you create what we call a recovery vault, an Azure Site Recovery vault. A vault belongs to a region. That's a way to say which region you want your metadata to reside into. Then you download the provider I showed, and there's a registration file. Previously, we used to require you to do work with certificates. Now, recently we simplified. We heard a lot of feedback that the certificates were cumbersome, it was complex to deal with them. So we simplified it by providing a registration file. You just, after you create the vault, you download a registration file, and the certificate is self-contained into that. Post that, you deploy the provider on the VMM. For protecting into Azure, you will require an agent on all the hosts that are going to participate in the replication. So you deploy the host on the host, deploy the agent on the host. After that, the VMM data is pushed to Azure Site Recovery. All of it is in a secure manner. We only do outbound communications. There is no incoming communications. We work with proxy. It's all over HTTPS, so standard firewalls. In this diagram, I've just shown Azure in two logical units. One is to show the service, the other is to show the storage and the compute and all. It's all Azure, but just to show that that's the secondary side, and Azure Site Recovery is the one orchestrating. So I've split Azure into two logical components here. And once the VMM is connected, post that you start creating your VMM clouds, and then you add the VMs. For example, here you see an AD, a SQL, and a line of business application. On the secondary side, in this case the Azure, you create corresponding storage accounts. Storage accounts is the place where all your VM's data will be replicated into. And then you configure protection of the clouds. I'll be showing all of this in a demo of how you would configure the protection of the clouds. After that, Azure Site Recovery takes over, and it starts monitoring the health of your virtual machines replication, of your clouds, everything. Also, once the virtual machines need to fail over, it's not enough that the virtual machines come up in Azure. They need to be connected to the right network so that end-to-end business continuity is achieved. For the same, we have a feature called network mapping, where you create networks corresponding to the networks on the on-premise in Azure, and then you map them. What we do with that mapping is, once a VM which is connected to a network fails over, we connect it to the mapped network, and I'll show you how that happens using a schematic representation here. So here I have a Windows Gold cloud that's protected to Microsoft Azure. It has virtual machines. It's a multi-tenanted cloud. It has virtual machines belonging to sales and marketing, the red and blue. And on the other side, I have created the network marketing recovery and network sales recovery on the Azure side. The middle is the dividing portion. What I do is then I do a network mapping to tell Azure that ASR that when a VM that's protected to network mapping fails over, connect it to network mapping marketing recovery. And the same I do for the sales. Let's see what happens when I do a failover. When I click on failover, that's when the virtual machine is actually created. So far, a virtual machine was not created. The virtual machine gets created only when you do a failover. Till then, it's just blob storage. There's only storage. Only the VHDs reside on the storage. And the VM is directly connected to the network of choice based on the mapping. And same with the blue, the sales. This way, you're able to get the right network isolation and end-to-end business continuity. This is a key thing because a lot of customers we hear say that, hey, I have a plethora of networks, a lot of VMs. Getting them after I fail over, I need to manually connect them to the right networks, and that's a lot of time, and it impacts RTO, recovery time objective. So with this, you're actually able to automate the failover from an end-to-end perspective. Some of the considerations that about networking listed here. For example, we connect VMs to the map network. We assign IPs. For connecting back to on-premise, there are two options you have. One is a site-to-site connectivity connection, which Azure provides, which is basically in case you have two sites and the first site goes down, you move your workloads over to Azure, but the other site continues to access those workloads using site-to-site connectivity. At the same time, if you have a laptop which is connecting to the corporate network using a VPN, it could use a point-to-site connectivity connection, and I'll show you how that can be done as well. And over in TechEd, I heard a lot of people saying, hey, I have huge VHDs, 300 gigabytes, sometimes a terabyte, more than a terabyte. Sending it would probably take me a couple of weeks or so. So we have certain options here. Definitely, ExpressRoute is a preferred option currently, where you could use ExpressRoute to send large amount of data and achieve throughputs of more than 1 GB. Then we have built optimization so that we transfer only the changed blocks. We recently worked with WAN optimizers. We worked with Riverbed. We worked with working with WAN optimizers where using a WAN optimizer that's sitting on the edge on the on-premise and in Azure, you could go get up to 74% savings on the network. So this way you can send large data to Azure. Also, at times, there is a requirement that you do not want to clog the network only for replication. So through the host agent, you could actually throttle and say, my replication should use only 30% of the bandwidth that's available. So let's look at about the demo. So for the demo, here's the setup I have. I have a client running there, which is connected to the corporate network using a Corp VPN, connecting to the VPN server. I have a couple of servers, a SharePoint and a SQL, which is backed by a SQL server. And I have RDS server split into a RDS, the front end, the broker, and then the back end, which is hosting all the applications, Office applications in this case. And now I have a site-to-site VPN. So that's a site-to-site VPN between the VPN server and the prod network. And also the client is connected using the Azure point-to-site. P2S is point-to-site, S2S is site-to-site, connected to the prod network. I also have created upfront a test network into which I will do my test failovers. I will have my clients there and connect the clients to the failover VMs to test it out. And I have storage. Let's see what will happen once I turn on replication. It will start sending the blobs over. It will replicate the data. And as churn happens, it will continue to send that data. And when I do a planned failover or a migration of SharePoint, when I want to actually move SharePoint over to Azure and I say, I'm done, I want to reduce my footprint on-premise, I want to run SharePoint from Azure itself, you do a planned failover. When you do a planned failover, you see the SharePoint and SQL have gone gray. That means they're shut down as part of a planned failover. And then at the top, in the prod network, you would have seen SharePoint and SQL have come up. What we did is we shut down the VMs here, send the delta over. So this is zero data loss. With planned failovers, there is zero data loss. You do not lose any data, and the virtual machines are brought up there. And the second demo that I'll be doing is a test failover, where I will take the RDS server, I will do a test failover, so it will bring up a replica of it in an isolated network. The network will be provided as an input during the demo, and then I have a client inside that network pre-created. I'll test from that client to show that the RDS server is actually running there. Okay, let's go into the demo. So I'm switching over to my laptop from where I'll do my demos. So here I have the client, which is showing the RDS server, where I have Word, Excel, calculator, etc. installed. So I can launch the Word here to show that it's working. And at the same time, so that's my Word running on the on-premise. At the same time, I also have a SharePoint server running on which I have a wiki, where I have created a wiki where Barcelona venue is huge. I guess all of us will agree on that. I'm going to edit that venue, the wiki here. So I'm going to type up something more here and save it. What I will do is, after saving the wiki, I'm going to do a planned failure of the SharePoint and show that this sentence, that's so true, actually comes up on the other side. And I'll do a test failover of the RDS. At the same time, folks, we heard that Linux is a very wanted workload to run in Azure. So therefore, I've thrown in a Linux demo as well yesterday, based on the feedback we heard from people. And what I will do is with Linux failover, so I'm doing a planned failover of the SharePoint. I'm doing a test failover of the RDS. So that leaves unplanned failover. So I'm going to do an unplanned failover of the Linux VM. And there I'll show that you can actually retain the IP of the Linux VM post failover. So there, retaining the same IP works for some limited IPs, but whenever it does, you can actually retain the IP after doing a failover, and I'll show all these three now. So I'm going to now switch over to the Azure Site, the portal. So this is the portal where I have pre-created recovery plans. I'll show how these were created, but I'll first start with the demos. So I'm going to take the SharePoint recovery plan, do a plan failover. So what this shows is that it's going to fail over from the on-premise Fabricam VMM into Azure, and the two virtual machines will be failed over. I'm going to say OK. Then I'm going to go to the RDS. I'm going to say I would like to do a test failover of this one. So I'm starting all these three. I'll go show how we arrived here, and the end of the demos show that they all completed. And then here it allows me to choose whether I want to failover without a network so that I can RDP into the server and check that things are working, as well as choose a network. Since I already have a client created, I'm going to use Azure Test Network. So that's my test failover also started. And then I'm going to take the Linux RP. So that was my SharePoint, my RDX, now my Linux. And I'm going to do the third button, which is the unplanned failover. And here again, it's going to ask me whether I want to do an unplanned failover. Here it gives me an option to actually shut down the virtual machines on the primary. There are times when you're hit by a disaster, but you want to salvage as much as possible. So in a best effort possible, if you know that the primary is still up, you could choose to turn this checkbox on. Then we will try to salvage as much as possible and then proceed with the unplanned failover post that. So then I'll say, I want to do an unplanned failover of the Linux. So now all these three recovery plans are executing. How did I arrive at this? Let's take a look at that. And then I'll go back to showing that they completed. To start with, the getting started is a place where we show the steps that are required in sequence that are required for you to get here. For example, it talks about preparing the VMM server. I showed that in the schematic a few minutes back. So you prepare the VMM servers. For that, like I talked about previously, we used to have the certificates. That was the number one feedback. We heard that it's a little complex. People were getting stuck with that. So therefore, we added a feature called a registration file, which using the registration key file, you could actually avoid the certificates altogether. And then you create an Azure storage account. Then you download the agent for the host. After that, after you're done, I've now already pre-configured a VMM server. I've already taken a Fabricam VMM. I've already pre-configured it to talk to Azure. I'm going to skip that in this demo. I go to what is called the protected items. Protected items here show the VMM clouds. VMM clouds are an abstraction or a pool, a logical pool of resources like compute, network, and storage. So here I have a bunch of clouds. Most of them are showing that they're protected. I have one unprotected cloud called Fabricam. I'm going to click into that. It says that you can configure protection settings for virtual machines in this cloud. I go to the Configure tab. I choose the target. So the target can be VMM or Azure. You'll notice the consistency here. Independent of whether you're protecting between two VMMs or protecting from VMM to Azure, the experience is exactly the same. So if you're moving from on-premise to on-premise, from on-premise to Azure, the learning curve is very minimal with Azure Site Recovery. So in this case, since I'm going to go for Azure, I'm going to choose Microsoft Azure. There's a subscription you could choose. In this case, I'm going to choose the same subscription. I have only one subscription. Christian will talk about how different subscriptions can be used in a different scenario called hosted to Azure. And then I choose a storage account. In this case, I'll choose, say, a dev test. We support encryption at rest. So encryption at rest for certain businesses, for compliance reasons, customers want, even though Azure is fairly safe, customers want to encrypt storage, data at rest also on stable storage. The downside of doing an encryption will be that when you want to recover, the time to recover will go up because we need to decrypt the entire data. So if you have like a large VHD and we need to decrypt, it will take you time when you do a failover. So For your compliance needs, we do recommend that you turn it on. But if you do not need it, we recommend that you do not turn on encryption because the RTO will be higher. And then we support copy frequencies, 3 copy frequencies, 15 minutes, 5 minutes, and 30 seconds. So yes, we support as low as 30 seconds, that near sync replication to Azure. So in this case, I'm going to say 15 minutes is fine because it meets most needs of workloads. We also support ability to store a history of recovery points, for example, up to 24 hours. So you could say, I'll choose one recovery point. I'm OK with one recovery point. And we also support what is called application consistent snapshots. Certain applications, when failed over, if the snapshot is not application consistent, they might fail to recover. So to ensure that you always have a guaranteed recovery point, you could turn on application consistent snapshots. I'm going to say every hour I would like an application consistent snapshot. That's a bit aggressive. We can turn that down. And during application consistent snapshots, we take VSS snapshots into the guest. You could choose to say my replication, when the replication starts, right? This is called the initial replication, the bulk of the data going across. That has to be done at an off-peak hour. So you could say, I want that to happen, say, maybe in the late in the night, say 8 p.m. And then I click on save. What this does is it prepares the fabric. It prepares the entire fabric of all the hosts in the clouds are now prepared so that the virtual machines in that cloud can be protected. I already have some clouds protected. So I'm going to switch over to one of the clouds that is already protected called SharePoint. Post-protection, this is the cloud that is already configured. It is showing which configuration settings can be changed post, and some of the settings cannot be changed. Some can be. Post that, you can start adding virtual machines. So here I have 2 virtual machines already protected, CounterSource SharePoint and CounterSource SQL. I'm going to show how we can add another virtual machines. So I have another test machine which I have not protected. It allows me to, so Azure, when you create a VM in Azure, it requires you to call out the operating system and the operating system disk. So previously you had to set that in the VM, and that was another feedback we heard that we miss out on that step. It would be cool if it can be done in the portal itself. So we now took the feedback and fixed it. So now you can actually call out what the operating system and the disk is right from the portal and turn that on. So now the the test VM will also start appearing here. And so here, if you recall, I had done a planned failover. It's showing me that a planned failover is in progress. That's the first step of the demo that I had started with. Once I have turned on protection, I can go. So the Context Test VM has now started and is showing that it's enabling protection. The target size is of interest. So let's look into the target size. So once a VM is protected, you can change its properties. By default, we select a size based on the size on premises. We do a best match. But based on your needs, either for cost or for performance, you might want to increase the size, make it a better size. You probably go even for the G size that was introduced recently. Or for cost reasons, you might want to bring it down. So you can change that here. You can change the size, etc. here. Also, Azure has limitations on the size names that it allows. So you can edit the name. In case you had spaces in your names on-premise, Azure does not like that. So we allow you to change the name, and then it will come up with a new name. So now we've seen how we can configure the clouds. We've seen how we can enable protection on the virtual machines. Let's look at how we do network mapping. So for network mapping, you go into the Resources tab. We go to the Networks tab, and we select the source VMM, in this case the Fabricam VMM. I had selected it before while doing a dry run for my demo. And then you select the target location, which is Microsoft Azure. At the bottom, you see a source and target network list. So this is showing that, for example, the one that is selected and showing, it's showing that the CARP network is mapped to Azure network. So my CounterSource, the SharePoint VMs were connected to CARP on the on-premise, like I showed in the diagram. When it fails over, it will connect to Azure network. And so that's what this is showing. Let's look at how we create a recovery plan. So we've now taken care of compute, we've taken care of network, we also take care of storage because during the cloud configured, I called out which storage accounts I should use. And what I'm going to do now is I'm going to create a new recovery plan. So I'll call it Ticket Demo SharePoint. And it's going to be between Fabricam VMM and Microsoft Azure. And I will choose the cloud called SharePoint. Here I see that there are 3 VMs, but I only want to take 2 VMs into my recovery plan. So that's it. With that, I was actually able to put all the virtual machines belonging to SharePoint. If I had more, if I had a farm, a bigger farm, all I would have to do is those 2 steps, 2 screens, select all the virtual machines, and then it'll create the recovery plan for that. That's not enough. The recovery plan, virtual machines need to come up in a particular order. There's a dependency modeling, what we call dependency modeling, where the SQL has to come up before the front end does. So what you do for that is we create groups. Recovery plan provides groups. Groups are ways to do dependency modeling or create sequential list of virtual machines. For example, now I have in group 1 both the VMs that I recently added. I'm going to say that the SharePoint should be started post. So now it has moved it into group 2. So previously both were together, now it's in group 2. So now I have SQL and SharePoint in different groups. And the way when you do a failover, group 1, the VMs in group 1 will all come up first, followed by the VMs in group 2. I click on start, click on save, and then my recovery plan is committed. That's not all. There are times when we need to do scripts. For example, you might want to inject an IP into the SharePoint. So what we could do is we could add a script after all the virtual machines have shut down. Let's call it, say, set script. And then Azure Automation, the service that was recently announced as GA, we use that to help you run books and script your entire recovery. So let's say I will choose set VM IP. In this case, it's also allowing me, in case while failing back, if I need to run a different script, I can do that by selecting this box. But since I don't need to set the IP on the way back, it will work based on the on-premises. Now what this has done is it has added a separate script at the all groups shutdown, and I can save. So with these few steps, I was actually able to create a full recovery plan for my SharePoint application. Now, how does Azure Automation work? I'll quickly show you that. So Azure Automation, like you go to a different, I have these tabs opened. I have the IE tabs opened for different services. For Azure Automation, you go into the Azure Automation service here. I have 2 subscriptions here. I go into 2 accounts here. I go into the Contoso account, and I can see the list of runbooks. So it lists the set of runbooks. So for the Linux IP, like I called out, for the Linux VM, when I failover, I want to retain the static IP. For that, I have a pre-created runbook. I'm going to show the runbook itself. So the script is available here. For example, you have a small script where you get the this is the GUID this is the GUID of the VM that you want to set the IP for. This is the actual IP. In the script, you actually connect to Azure. You select the subscription in the Azure. Then you get the context of the virtual machine. If the virtual machine context is not 0, then you get the actual Azure VM and set its IP using set Azure static net IP, VNet IP. So what we have done is we have done a first-class integration with Azure Automation, For example, you will see that recently I ran I used this in the scripts in the runbook, and it will show me the list of instances that were run. So that's Azure automation. Now, I also wanted to quickly show that with Azure Site Recovery, there are a bunch of things that need to come together for it to work. The other thing that needs to work really well is networking. So let me show. Okay. Showed me that there's a timeout, session timeout. So networking, I talked about, there are two things. One is a point-to-site, and the other one is a site-to-site. So I'll show you how you could create networks with point-to-site and site-to-site. So you go into plus new, you choose network services. Just waiting for it's loading yet. So all my tabs have timed out on session, so just give it a second. So what you do is, while you're creating the network, you call out whether or not, so here, you call out whether or not, so you choose network services, you choose virtual network, and you say custom create. You give it a name, say TechEd demo. You call out where you want. In this case, I'm going to leave it as the default. And here, you call out the DNS server. I have some set of DNS servers set up before. Here, you choose whether you want to use it for a point-to-site and site-to-site. So this was enhancement Azure did to support both point-to-site and site-to-site from the same network. You could also choose express route if you're set up express route. And then you call out what's the IP of your point-to-site, what IP. When you are doing point-to-site, the clients that connect, they get the IPs based on the address that is provided here. Similarly, when you do site-to-site, you call out what's the subnet and the address space that is being used for your site, the VPN here. I'm not going to create the network here. And post the creation of the network, this is how it will appear. I have an Azure network in which I have provisioned both point-to-site and site-to-site, and also provisioned, that's why the gateway is provisioned. When a point-to-site or site-to-site is created, a gateway is required. After that, Azure provides you 3 download links, one for a 64-bit, one for a 32-bit, and one for a VPN device. So in case you need a site-to-site, you download the VPN device. In case it's a 64-bit, you download a script. It's a small script. You need to run through it, and then you're able to connect to Azure point-to-site. For example, here, I have an Azure point-to-site, and all I need to do is click on connect, and then I'll be connected to the Azure network. So that was about, so we covered the VMM creation, the VMM registration. We covered configuration of the clouds. We did enable DR. We did network mapping, and we also saw how recovery plans were created. At this moment, I'd like to call Christian to show his demo, and then once he completes, I'll show you that the demo is actually completed, and that the RDS, there's a test failover running, the SharePoint is running in Azure, and that the Linux is actually failover with the static IP. Christian, thank you.
Should I?
Sorry, I can talk to that. You can skip that one.
Yeah.
Oh, sorry. Let me talk through this. Sorry. So, sorry about that. So, like I talked about, we recently announced about a couple of days back a hosted to Azure scenario. For that, what we needed is in the enterprise, in the place where we are showing the scenarios, they were all enterprise to Azure, or where all the virtual machines could actually reside in the same subscription. You do not require isolation. But with hosters, they require isolation for the tenants. So, for example, I'm going to show a schematic to show the same. Here, I have a hoster running Microsoft Azure Pack and VMM with the DRP installed. And then I have a tenant 1 created, which creates some virtual machines. For the same, the hoster would create a dedicated subscription for the tenant 1, set up VM replication to that account, to that subscription. And similarly, when the tenant 2 comes on board and creates his virtual machines, he will set up a VM replication for tenant 2. What this allows is when the virtual machines fail over, the tenant 1 can access his virtual machines independently. He can go to the portal and access his virtual machines. He can shut them down, do maintenance or patching of the same, and same for tenant 2. At the same time, the billing account stays with the hoster. The billing is with the hoster, and he can then provide this as a managed DR. So this will be a managed DR where the hoster is the one doing the test failover, the hoster is the one doing the failovers. Self-serve DR is something we see as at least 2 to 3 years out. It takes a lot of maturity overall in the environment to be able to provide self-serve DR. Hosters, we're talking to hosters also, they felt that managed DR is where they and their customers are comfortable with. So what this will allow is, once there is a failover, you will notice that the virtual machines come up in their own accounts. So to call out again, tenant isolation, the hosting's HSP, the hosting service provider, owns the billing of the Azure subscriptions. He creates the own subscription into which the vault is created. Tenants do not have access to the management subscription, so therefore they cannot compromise each other. There is security maintained, and then HSP creates a separate account or subscription for each tenant. And like I called out, given managed DR focus, DR drills are triggered by HSP. So thank you, Christian.
Thanks, Manoj.
Sorry.
Okay, everyone. My name is Christian Nessa. I'm a CTO at a company called Lumagate. So we are basically a system integrator that is dealing a lot with the CloudOS stack. So what I would like to present and highlight as part of this session is one of our clients, which is Every. And Every is one of the biggest IT providers in Nordics. We've been working close with them for the last 8 months or so, and we have sort of gone from zero to a full-blown private cloud environment using Azure Pack, all the resource providers in Azure Pack, and so on and so forth. So the context here will obviously be disaster recovery scenarios, and I will show some of it, what we have done. So as you can see, they have quite a massive data center. They are also part of the CloudOS network, a silver member. And they have hosted services as well as many on-premises customers as well. So a couple of scenarios we were dealing with is obviously hosted to hoster. We have seen some announcement here at TechEd, like the new update rollout 4 for System Center Windows Azure Pack that basically enables integration with Azure Site Recovery, that you can provide that as an add-on to a plan. Obviously, this is something we are dealing with for Every as well. So in their private cloud with the Azure Pack, tenants can now enable this on their own. In addition, they have branch offices, so they can use Azure as a target for the for their disaster recovery solution. And last but not least, the hosted to Azure. We finally have a way to provide the same level of isolation also in Azure for the tenant point of view as Every is providing within their own cloud environment. So the solution for everything, of course, is Azure Site Recovery. It's the umbrella so that no matter what scenario we are aiming for, we are able to use a consistent experience to enable this. So for the hosted to hoster, we are dealing with multiple VMM management stamps and VMM clouds. We use Azure Site Recovery to do the orchestration and also a level of automation here, as I will show you. For the enterprise to hoster, same experience. We are pointing to Microsoft Azure as a target. And for the third one, the hosted to Azure, we orchestrate internal DR to Azure as well as for customers into their dedicated subscriptions. So with that, I will jump into a demo. So what I'll show is try to cover this end to end. So from a private cloud perspective where you have VMM, you obviously need to register with the Azure Site Recovery Vault. So as part of the update rollup 4, this is now renamed to Microsoft Azure Site Recovery. So here you can see a management stamp that is registered to a Site Recovery Vault. We need to provide some level of automation as well. So the scenario here is that we have tenants accessing the cloud in every data center through the Azure Pack. So we are using dedicated clouds because the disaster recovery is mapped from the VMM cloud into the tenant subscription in Azure. So that's why we need to isolate using different clouds in VMM. We can have a look at the cloud in VMM. We see that we send configuration data into Azure. We can see that protection is enabled and that the recovery cloud is Microsoft Azure. Now, to ensure automation as part of this, each and every time this customer deploys a virtual machine to this cloud, the virtual machine will be enabled and automatically replicated to Azure. It's a simple setting on the VM template where you go to the hardware configuration and you will have some user interface changes once you have associated with Azure Site Recovery. So here we have an option. So we can see that this template should be targeting a cloud that is enabled for protection. So once it's deployed, it will be enabled, and the Azure Site Recovery will note this and replicate to Azure. So if we go into the Azure Pack portal, you can see that this is not Microsoft Azure. This is an on-premise Azure Pack solution, recovery.systemcenter365.com. You can see that we have quite a few virtual machines. Now 3 of those virtual machines are now stopped. And this is because we have done a failover. So if I go to the Microsoft Azure portal as the service provider, so please remember this is manage DR. I can drill into the Fabricam protected cloud. So this is the same cloud you're seeing here in VMM. I can drill into that cloud. And here you can see the virtual machines. As you noticed, in the Azure Pack portal, I have 4 virtual machines, but only one of them is running. So going into Azure, we can see that the active location for the top virtual machine is in the private cloud, and for the rest, they are running in Azure. So if we log into this particular tenant subscription, meaning the tenant can actually access the Microsoft Azure portal, log on with their credentials, they will only be able to see their virtual machines post a failover. So this is now possible because we can target different subscriptions in Azure. So this lets us create a dedicated subscription for each tenant we want to protect. So we provide multi-tenancy and isolation in Azure as well. So that's for the demo.
Sure. Thanks, Christian. So let's...
Thanks.
So let me go back to my demos and see where we are. So we had done the failovers, 3 failovers. We did test failover of the Linux. We had done, we did an unplanned failover of the Linux. We had done a test failover of the remote, the RDS, and then we had done a planned failover of the SharePoint. Actually, all 3 have done, so for example, here it's showing that it's commit waiting. Once the failover is done, we need to commit the failover to show that I do not need the recovery points further, and I'm good with the recovery points to post testing. So what we do here, so you'll notice that there are links, easy links to take you from the recovery plan to the job of the that is executed. For example, here, we have a very rich infrastructure of jobs. DR jobs are long, can take time, and it's very important that we track and audit them so that you can present them for compliance needs, or in case it's required for records, or in case you need to present it to your customers, keep them so that, and also the audit helps you to ensure that it's repeatable. So here you're seeing the list of tasks that got executed as part of test failover. For example, we created the test environment here, and then we did the recovery plan failover. We did actually the group 1 was first started, like I called out. The RDS was again split into 2 groups, the Office apps and then the broker or the RDS itself. And then post that, it's now complete. So basically after that, it stops. It waits for you to indicate that the testing is completed. Let's see whether it came up, the RDS client, whether it came up. So I have an isolated client running in the Azure Test Network. I chose an Azure Test Network as the network into which I wanted to do a failover, test failover of RDS. So in that, I already have a client running. I'm going to start. And here, the RDS has, so we have now a replica of the RDS running in a test environment where I can do my testing to ensure that RDS replication is going kosher from an isolated client in an isolated network. So that's the first demo that got done successfully. The second demo, let's go back and see which was the second one. The second one was about the Linux VM, which we did an unplanned failover with the static IP. Let me show you the actual recovery plan for the Linux VM. So for the Linux VM, I had one VM, and I had added a script called set static IP. And here, you will notice that the Linux VM is running here in Azure. Now, this is the list of virtual machines running in Azure. You'll notice that the contextual Linux VM is running in Azure. So is the SharePoint and the SQL. So contextual Linux VM is running. And let's look at the IP on it. So it's the IP that was in the script, the 10.0.0.112. We can go back and check that. So I'm going to go back to the jobs view. The job shows all the list of jobs that got recently done. Here is the unplanned failover of the Linux RP. The step that got executed. I can go and look at the details of the step. For example, all the details of the name of the subscription, the environment, the account that was used. And to actually see the job details of the Azure automation, we provide a link from here. So I can click here and see the job that got executed. Or I could actually go to the Azure automation. And go to the actual other sorry, yeah. So here, this is the job that got recently executed. And here is the IP. So the static IP that you wanted for the Linux VM has been set through the script. So that's the first, the second demo, that was the Linux VM. The first one was the RDS. And let's look at the SharePoint, the migration of the SharePoint. I'm going to go back to my recovery services vault. And here you will notice that the SharePoint is also completed and it's waiting for commit. I'll go to the jobs, ensure to check that it's actually completed. The planned failover here is completed successfully. And I'll go to my client. and go to the wiki and go to the wiki that I edited. There is the change that I made. This venue is really long, and I had added that's so true. So what we did is with the planned failover, whatever changes we made was actually committed, transferred over to Azure, and then it actually came up in Azure. Now that I have done the failover, so planned failover, what I'll do is I'm going to go back and commit the failover. What this will do now is it will ensure that the failover that I have done, I've tested that it is kosher. I will ensure that post this, the failover is actually committed so that I can continue progress. Now, usually, in case you want to come back, you would do another planned failover back. Instead of that, what I could do here is I could actually say, I am done, I want to stay in Azure. I could then go and do a delete replication or a disable replication, such that that will ensure that you have done actually a planned migration. Let me see if I can show you the fail back. Once this completes, I can show you the fail back quickly. Let's drill down a bit more into the cloud services. So when VMs are created, they're created in cloud services. The names of the clouds, the way to decipher the names of the cloud services is it's usually the name of the virtual machine or the recovery plan. For example, we just recently we ran the SharePoint. So we created the SharePoint RP. The name of the recovery plan was SharePoint RP, and we add a GUID to distinguish it. The same way when we ran the Linux RP, here's the Linux RP, and the virtual machine is created inside that. I already showed you the virtual machines created for all the Linux, the RDS, the SharePoint, the SQL, all of them are here. So let's see so the commit is completed. Now let's see how you would do a failover back to on-premise. So this is how we support. I talked that we support a first-class way of failing back to on-premise. Now, failing back to on-premise can be done in two ways. One, the first option, which is synchronize data before failover. So when you are failing back, of course, you're failing back with zero data loss because you do not have a disaster. You're failing back now that you're done, your on-site is back, you want to fail back. At that time, you do not want to, of course, have data loss. So there is no data loss. But there are two options. One is you could want to minimize downtime so that you're not having a loss of productivity, a loss of workload running. So what you could do is do synchronized data before failover, in which case what it will do is so we do not have continuous replication back from Azure to on-premises. When we fail back, we do a data synchronization. We do what we call a checksum and check all the blocks that change and send only those in an optimized manner. So if you want to minimize downtime, we choose the first option, in which case we will do a checksum first, a resync first, and then you shut down. You indicate that, hey, I am done. I'm ready to do a downtime. You choose the time. I'm ready to go for a downtime. You shut down. You say, go ahead. At that time, it will do a delta resynchronization and complete. This is slightly more resource consuming because it does a data synchronization twice, once before the shutdown, once after the shutdown. It minimizes the downtime, but it increases the resource consumption. In the second option, where you synchronize data during failover only once, that is, you want to minimize the amount of resources you have. So basically, let's assume you're doing this on a weekend, you're okay to have the weekend downtime, then you could choose the second option. So based on whether you want to minimize downtime or you want to minimize resource consumption, you would choose the option. But in this case, like I said, I do not want to do either. I do not want to fail back. SharePoint has moved into Azure. It's a planned migration. I want to stay in Azure. I'm not going to do a fail back. So let me see the other two jobs that I had triggered, which was about the cloud and the VM protection. If you remember, there was a Fabricam cloud that was unprotected. It's successfully protected and configured for protection now. So now virtual machines inside that cloud can also be triggered for replication. And then I had also protected another VM inside my SharePoint cloud. There are two VMs protected at the start of the demo, SharePoint and the SQL. The context store test VM is also protected. It chose an extra small size based on its size on the on-premises. I can go ahead change it if I wish. You can change the network. You can change its name. So with that, all the demos went through. We had SharePoint planned migration. We did Linux unplanned failover. We did RDS test failover. So now I'll switch back over to my presentation. A quick summary of the capabilities that protection to Azure has. You can do using cloud configuration and network mapping at scale configuration. So actually, with multiple hosts, a lot of networks, you can actually achieve at-scale configuration. I showed you that there are 3 RPOs we support, 15 minutes, 5 minutes, and 30 seconds. So based on your apps, you can change the RPO. I showed the extra small that was used for the context store test VM. We auto-size the size. We pick the size based on the size of the on-premise, but user can change. Like Christian showed, the data resides in the customer or the tenant storage. You could actually store using encryption, use encryption when you need it for compliance. Automated failovers, recovery plans which support scripts, which support dependency modeling, and which support manual action. I did not show manual action, but excuse me, not everything can be scripted. There are certain things that need to be done manually. You could actually insert a manual action inside a recovery plan. So when the recovery plan is executing, it will wait for you to come. You can take your manual action and say, continue, it will proceed. And then we have failback as a first-class gesture. I showed the dialog for that, and it has 2 rich options. And like I talked already about the fact that recovery plan has dependency group, manual actions, and Azure automation. So Azure Site Recovery is a single solution for your entire infrastructure. It supports Hyper-V, VMware, and physical. It has 0 RPO or near sync RPO solutions with the Azure Site Recovery using Hyper-V replica. Also with SAN now we actually can do 0 RPO. It has an ability to do enterprise class application. We just showed demo 2 of them. I did SharePoint, I did RDS. You could do the others. You could do just SQL. You could do, in fact, one of the hero applications we talk about is you have SharePoint running inside virtual machine, and the SQL is physical. You could actually do the virtual machine protection using Hyper-V replica and use SQL always on to protect the SQL. And then using Azure automation, you can fail over the entire thing in a single manner, where you could actually say, fail over my SQL using an Azure automation script, and then fail over my SharePoint, so they'll come up in the right order. You could do that, or you could, like I did in this case, I had SQL also running in a virtual machine, and I was protecting it using Hyper-V replica. We also, like I talked about, we support the different types of devices, storage devices, using Hyper-V replica. Since Hyper-V replica works on heterogeneous storage, you could have file shares on the primary, you could have DAS on the secondary, you could have CSVs and DAS. You could mix and match. It does not require homogeneous networks, which is a requirement with a lot of technologies. And also, with the SAN, we are able to take out the biggest blocker we had, which is basically support for clustering. We are able to support clustering, get group consistency. Also, like we talked about, we could do a very low cost, a very simplified DR, either to a public cloud, to a service provider cloud, or to your own cloud, either between 2 sites of the same enterprise, or from enterprise to a hoster, or from enterprise to Azure, in all of them in exactly the same manner, with the same configuration settings, in a consistent way, so that you do not have to learn every scenario in a new way. Last but not the least, to talk about this simple, consistent, unified management experience. So, for example, you might have what we call a robo scenario, or remote office, branch offices, multiple offices wanting to get protected into Azure. You could have a complex setup where you have maybe Amsterdam, London, Brussels, all of them protecting between them. Any of these can be achieved from a single management console. Today, all the package software DR solutions provide a peer-to-peer view. So if you had 3 VMMs, one in London, one in Amsterdam, one in Brussels, you'll probably see London to Amsterdam in a separate view, Amsterdam to Brussels in a separate view, and so on. But in the Azure Site Recovery, you see all of them in a single console. So therefore, you're able to get a simple, consistent, unified management experience. We have a lot of tracks on BCDR for backup, disaster recovery, and so on, and including clustering. So this is the list of sessions. Some of them are already over, but you can watch the recording later. I will be available at the business continuity booth along with my colleagues. We have some of us, like from the SAN and from the hosting service provider scenarios. All of them will be present at the business continuity booth. At the same time, my email ID is listed here. That's mkjain@microsoft.com. Feel free to send me a mail. Would love to hear from you, any feedback, or if you would like to get help on any of the applications that you are trying, or you have a different environment or a particular complex deployment, would love to hear about it. I have my colleague here with me, Abhishek, as well, so we'd love to hear from you. We also believe in a lot of blogging. We have, since the product cannot do everything that you need, we have blogged about some of the workarounds you can do, some of the tips, the best practices tips. So we have the list of the blogs. Similarly, Hyper-V Replica, the technology that does a lot of blogging. We have other blogs from Microsoft listed here. A bunch of resources here for you to use. We have some pricing guiding. Also, capacity planning is a favorite topic for a lot of people. How do I plan the capacity for DR? How do I ensure that when DR happens, I have all the capacity that I need? So we have a capacity planning tool out there. We have a rich wiki, MSDN forum. And here's some more information. That's it. Please do evaluate. Any questions? Thank you. Yep. It's a great question. The question was, do we support VHDX? Today, we do support VHDX. Azure does not support VHDX today natively, but ASR supports VHDX. What we do is we convert VHDX into VHD, failover as a VHD, and on the way back, we convert back to a VHDX. So we do support VHDX. Great question. The other thing, we do not support Gen 2 today. I'd like to know how many of you are using Gen 2 today, Gen 2 VMs. Okay, great. So we are working with the Azure team to ensure that they enable support for Gen 2. It's right now the top one ask that we have from customers. We're working on that. We do have other limitation about 127 GB. The OS disk that we support has to be less than 127 GB. We're working on that as well. But yes, the answer is VHDX is supported. Yes. Great. The question is VMM a requirement? The answer is yes. This currently is built on VMM. For, like I called out, at-scale configuration for getting all the scale requirements and other things, VMM is a requirement today. We are hearing feedback from customers who do not have VMM or are small-sized that VMM is not something that they would like to use for this. This is in our backlog on how we can enable a solution either with VMM residing elsewhere or without a VMM. But it's one of the top feedback. After Gen 2, that's a number 2 feedback. Yes. So the question is, with ESX server, when we are protecting, is there any limitation that we need to be aware of? Is that the question? So today, we do not support, like I said, that's coming soon. We do not support VMware to Azure. That's something that's going to come. Whenever it comes, it will still, so we will still be governed by whatever Azure limitations are. We'll be limited by whatever Azure capabilities are. So for example, if you had a VM with a OS disk that's greater than 127, it will not work in Azure even from an ESX server. It will be the same limitations we have from Hyper-V, which will apply to VMware. So the question is, what about the network requirements from on-premise to Azure? So there are two answers. One is network requirements for the replication itself, and other is a network requirement post the failover. So for the network requirements for replication, you just need a regular replication channel to Azure, so that your hosts are able to talk to Azure storage. It will be great if you had express route in case your size is large or if you have a lot of churn. So what you need is connectivity from your host to Azure. So that's during replication. Post failover depends on, like I called out, there are two scenarios. One is you have another site from where you need to connect. You have SharePoint, which is failed over, you have another site. So at that time, you will need a site-to-site connectivity. For that, the way I called out, you could connect a site-to-site, you could create a site-to-site connectivity, VPN, using the Azure gateway. Or in case you have a mobile workforce, which is working from like maybe a Starbucks or from home, all they need is a point-to-site connectivity, for which they need to download XC and run on their laptop. Okay, the question is, can we use what we call Azure Data Transfer, or ADT, and send the initial replication over? It's a great question. We're calling that import-export. We're not yet integrated with import-export, but that's also going to be very soon. We have that in the backlog. We hear a lot of customers wanting to replicate large amount of data. Currently, our solution is to use ExpressRoute or the WAN optimizers, but we are definitely looking into integrating with the Azure Data Drive Transfer so that you can actually courier the initial replication and get things going. Any other questions? Okay, thank you, everybody.